Here we are then, folks, with a question all about an acceleration time graph. Have a go and then hit play to see the explanation. So as I think I've mentioned on other videos, the acceleration time graph is not a very commonly used one in IB physics. However, it's getting a bit more popular. I think it's because it's one that we don't use that much in the lessons, and so it's a good chance to practice our application. We're going to use our graph to determine the final speed of the object at 8 seconds. And the first thing to notice here is that the graph goes from 0 to 10. So we're looking at 8 seconds here. We're going to match 8 up to 8. Okay, that's going to be important for later. When we think about here, we're going to find the change in speed using the area of this graph. And this may be something you've not been taught explicitly, however, it's something you can work out, which is that the area under this graph is equal to the change in the speed, or if you're working in vector terms, the change in the velocity. So in this case, we're going to use the fact that we've got a triangle, area is equal to b times h over 2. So if you notice here, we've got meters per second squared multiplied by seconds. That's giving me meters per second. That's going to give me my change in speed or change in velocity. In this case, as I mentioned at the beginning, 8 and 8, we're going to do 8 times 8, and we're going to remember to divide it by 2 because it's a triangle. We're going to get 64 divided by 2, giving me 32 meters per second. So this is actually the area, and it's also the change in speed. What we've got to do a quick check is what the starting conditions are, because we're told here at time equals 0, the object is at rest. We know the change of speed is 32, so we know this delta v is going to be 32. We need to know what that u is. Well, obviously u is equal to 0. So we have got a final answer there of 0 plus 32, 32 meters per second, which is why the answer here is B. The reason I go through that slightly explicit version is here is if you had the case where, for example, v was u was not 0. We may have a case, for example, that the initial speed was, I don't know, 18 meters per second, in which case you would have 18 meters per second plus 32, in which case your answer would be C. So just go back and check, make sure that your change in speed is equal to the actual final speed, because we began at rest.